Okay, AP Chem, we're going to do another BCA chart, limiting reactant, and percent yield problem together. This one's about DDT, which you might have heard of before. Probably most impactful before you were born, though. They used to use DDT as an insecticide. It's a synthetic organic compound that was actually created in a lab by a guy named Paul Mueller. DDT is actually dichloryl diphenyl trichloroethane. It is a organochlorine, and like other chlorinated aromatic hydrocarbons, the aromatic means that it has a ring structure to it, a benzene ring structure inside of it. The problem with these is they tend to persist in the environment and come concentrated at the head of the food chain. So nothing really tends to break it down, and that's where its problem lies. So its use is banned in many countries, which has its good effects and its bad effects. You might think to yourself, well, yeah, why would you want that toxic chemical in the environment? But the reality is it did kill a lot of insects, so much so that they actually had thought they had eradicated bed bugs entirely. And now that DDT is outlawed in so many places, bed bugs are coming back with a vengeance, which is unfortunate. But the other thing that is coming back is the population of American eagles. The American bald eagle was on the endangered species list for years, theoretically because of DDT. Then once we banned it in this country, they made a resurgence. And you can actually see bald eagles flying around in the right spots now. So it's kind of amazing if you were around for the whole story to unfold. Anyway, let's read this. DDT, an insecticide harmful to fish, birds, and humans, is produced by the following reaction. Chlorobenzene reacts with chloral to produce DDT, which is that dichloryl diphenyl trichloroethane, and water. So in a government lab, 1,142 grams of chlorobenzene is reacted with 485 grams of chloral. What mass of DDT is formed, assuming 100% yield? What's the limiting reactant? What's in excess? What mass in excess of the reactant is left over? And if the actual yield of DDT is 200.0 grams, what is the percent yield? So that's a lot of work unless you use a BCA chart. So let's do this BCA chart. First thing you got to do is change grams to moles. So 1,142 grams. I'm going to abbreviate chlorobenzene like this so we don't have to write out that whole formula. I add up the molar mass of 6 carbons, 5 hydrogens, and 1 chlorine to get 112.55 grams in 1 mole of chlorobenzene. So if we start with 10.147 moles, our given has 4 sig figs, so I'll just drag around 5 just to be safe about it. 485 grams of chloral, I'll just abbreviate that C. And if I add up 2 carbons, 1 hydrogen, 1 oxygen, and 3 chlorines, they get 147.378 grams in 1 mole, or 3.2909 moles is what we're starting with. So I'm going to rewrite our equation over here so we can do the BCA chart. So we need twice as much chlorobenzene as we do chloral to make that big giant compound, which is DDT. C14, H9, Cl5, and of course water. So BCA. The B is the given changed to moles, so 10.147, 3.2909, 0. Remember, the reactants get minuses, the products get pluses, and this one will be 2x, this one will be 1x, this one will be 1x, and this one will be 1x. So usually people don't have problems with BCA charts until this point where they say to themselves, now I have to figure out which one is the limiting reactant. If you don't know how to do this, you can set them both equal to 0 and figure out which one gives you the smaller value for X, if that is easier for you. But I'm going to give you a logical way. A lot of times logic is much easier. So I'm going to solve for X first, and then I'm going to talk to you about logic. This is simple algebra, guys, so if you're getting lost, ask questions. You can see to yourself that this is the smaller value for X, so this has got to be the true value for X. This is the larger value for X, so that doesn't make sense. So in that case, he's the limiting reactant. But if we didn't want to do that simple algebra, we could look up here and be like, okay, I need twice as much chlorobenzene as I do chloro. I look and say twice as much chlorobenzene. I don't have twice. I have more than twice as much. I don't have enough chloral to consume all the chlorobenzene. So twice as much of this would be like 6.6. I have plenty of this, so this is obviously the limiting reactant. My value for X here is 3.2909. So my equation for this guy becomes 10.147 minus 2 times 3.2909. That's going to tell me how much is left over. So it's going to be before minus change equals after. And in this case, it would be 3.5653 moles of chlorobenzene are left over. There's no chloral left over. And how much DDT will we produce? Well, it's just X. So 3.2909, 3.2909. You can see how many stoichiometry problems that saves us. So let's answer the questions now. What mass of DDT is formed? So this is moles because it's in the BCA chart. So let's do 3.2909 moles of DDT, and we're going to multiply it by the molar mass, which is simply adding up all of those elements in here. 14 carbons, 9 hydrogens, and 5 chlorines from the periodic table of the elements to get 354.462 grams. Multiply that out. My calculator is going to tell me 1166.498996. When I report this answer, I'm going to report it in 4 sig figs. But if I need to use that number for further calculations, I'm going to use the raw value. Which reactant is limited? And that's going to be the chloral. Which reactant is in excess? And that's going to be the chlorobenzene. What mass of the reactant in excess left over? So we're going to do 3.5653 moles of chlorobenzene and 1 mole of chlorobenzene, it's 112.55 grams. So in my calculator, I'm going to multiply this time to get an answer of 401.274515 grams. And this is chlorobenzene. This is DDT. So when I report my answer, I'm going to report it to 4 sig figs. Oh, actually, it's 3 sig figs. So we'll report this to 3 sig figs grams of chlorobenzene. If the actual yield of DDT is 200 grams, what is the percent yield? All of these calculations we did are simply a theoretical calculation that would tell us if everything went perfectly and 100% of what we expect to happen happened, that's how much we would theoretically, so actual over theoretical. Theoretical always comes from your stoichiometry calculations or your BCA chart. Actual comes from usually given, put the actual of 200.0 and the theoretical of 1166.498996 times 100. And that's going to equal 17.15%. I'm going to stick with that 4 sig figs because that's what's in 200.0. So that's my answer for this particular problem. And to